Hi guys. Today lecture is also we will learn about active power and reactive power. Oh, sorry. Here's active. Yeah. So what I wanna say is we previous lecture we learned about active power, right? Active power is actual usage, I said, right? So instead the reactive power, what I said was, for example, I gave you money and you didn't spend and store it and return it back. This concept is, we say reactive power. So here, the definition of reactive power is, I get it from the Google. So I've tried to read it. So reactive power is the part of complex, complex power that corresponds to storage and retrieval of energy rather than consume. On an AC power system, there are two kinds of power: real power that actually does work, and reactive power that enable transformers to transform, generators to generate, and motors to rotate. If you guys, understand how we could imagine, like with this word, what is that reactive power? What's the differences? If you say like real power is actual, actually does work, but reactive power that enable, like motors to rotate. Actually, motors rotating is actual working, isn't it? So we, with you know, uh, weird, or not weird. What I mean is, if we didn't understand the reactive power, you know what I mean? So we cannot understand this meaning. Actually, we are confused what it's saying. I guess just seem like the same meaning, you know what I mean? So let's see. Um, so first of all, we need to know about the general, load situation in the daytime generally. So here's V and power system, right? And here's many load. Like it could be your computer or the freezer, and it could be like parallel connected, right? So for example, just I will say now one load. So for example, general load is a motor, right? So motors, we could indicate in the circuit R and, you know, R, R and Q. But since motor is, coil, so we say this is L. I've made about this, uh, inductance and what I mean is RLC. I mean in the circuit. I made the lectures. So if you guys did understand why motors indicated L, just watch it there, okay? So we could say this is RL circuit. So if we change it, here's source R. Sorry, R L, right? So look at that. So I will drawing pager. So V, yeah, because there's always, later we will learn about how we draw the pager. But now I'm trying to do just a little bit explain. Don't worry about it. Just so first of all, this source is since we have a voltage system, we have a reference. We need the reference. So that's why the voltage source is a reference here, and L. So so look at that. So general situation, if we have a motor like a lagging means V pager is uh yeah, V is here. Uh, uh, I is here. Oh, sorry. Where is, um, yeah, I is here. So if we, see peak to peak here, V is faster than I, right? Peak to peak, if we compare, right? So we say we say this time is lagging. It's, behind. So the general, uh, load system, like a daytime, our current is like that. So V is here, I is zeta minus zeta. This is RMS value, okay? This is RMS value. So I wanna say is this part. Look at that. So we draw here and I is minus zeta, right? And here's zeta. So what I wanna say towards here, look at that. This part. So actually, I, has a P and Q if we see. I will explain, okay? Don't worry. So here, IP. Here, IQ. So I want to say is here's a cosine theta, right? So here's a cosine theta. And here, IQ is a sine theta here, this part. So it has a P and Q. I has a P and Q, right? So I try to explain more. So first of all, we will try to run it in the time domain. So V, if we change it to pager to the time domain, root 2 V sine omega t. And this part, IP part, I will trade IP. IP is active, current and reactive current here. What I'm gonna say, explain is. So t root 2, here's cosine, right? Root 2I cosine theta, but sine omega t. Because as I said, R in the R load circuit, Vi is same phase, right? That's why here it's same in phase. You know what I mean? Instead Q. So I will focusing on more. So if we, uh, try to do here P differential P P is Vi, right? If we no P is T dt is Vi cosine theta. This is we say active power. So which means in phase, and we actually use here this part. But instead we will learn we will see about this P reactive part. So it's the same. So from root 2 IQ part is root 2 I, here just sine theta, right? Sine theta, but sine omega t minus 90 degree. Why? Here, look at that. From V, I is 90 degree, right? So there's between them, there's major differences, like 90 degrees. So if I do the same process, the result is, V I sine theta is, reactive power. You know what I mean? Reactive power, we say. So yeah, this is about I explained in the math, but you don't need to remember about this math part. Just try to understand that today the concept, what is the reactive power? We will learn about it. Just this is the first step. What is the differences, active power and reactive power? You know what I mean? Active power is actual working, but we used. But reactive power, it actually we didn't use. You know what I mean? It stored energy and returned it back, like that. By the way, I will explain one more thing here. Compared to active power, the graph here. Look at that. Since okay, I explain. Sorry, I forget it to explain this. First of all, I explained it. Yeah, continue. So look at the guys here. First of all, I said we put here, and I is here, right? But between them there's a theta. But we want to know here this part, IQ part, right? And this part is IP part, right? So which means here's between them there's 90 degrees. So here 90 degrees. So if we here V and I, right? So first of all question is what's the lead and the lagging? The current is lead and lagging. Let's see. Look at that. If we compare peak to peak, current is not behind the voltage, right? So current is kind of faster position here, right? So we say this is lead. Current is lead. You know what I mean? Not lagging. So which means that this is like a capacitor. You know what I mean? Later we will learn about it, so don't worry about it. Okay. So look at that. Here VI, V is here minus, right? I is plus. If we multiply, which means plus minus is multiply minus, right? And here I is also plus, and V is also plus, which means plus. And if V is plus, I is here start minus, right? And minus. So you can see this yellow part. So what I said, gain, let me go give you, return back, give you, return back. This concept is reactive power. But instead, I said since it's active power is the same pace, right? So it's actually used and in same page, which means actually use. So what I want is, yeah, previous lecture. So if it's the same, here, this is V, and here, also I, same in pace, right? I. So which means the result was, what was it? P is plus plus, and minus minuses, right? Here. And if we, calculate the average value is active power, right? Yeah, that's it, the differences. So don't worry about it. We will, focusing on more about the reactive power, because active power is yeah, we know that, right? Actually use something, it's gone. But we will learn about the reactive power, because actually making rotors to rotate the part is here, prime mover part. So for example, if it's a generator, prime movers moving, right? It needs rotating, but it needs some power, like it could be a steam or nuclear or hydraulic power. So it's related, this actual rotating is actually related power, active power. But instead making magnets magnet inside the motor or rotor, so it needed reactive power. So actually our load needed active power and reactive power. So yeah, let's see more later. Yeah, today lecture is done, guys. Thanks.